On December 9th and 10th, a strong low-pressure system and associated cold front blew through the southeastern United States. This storm would go on to incite a tornado outbreak across much of the southeast, with a total of 18 tornadoes being recorded. The strongest of these tornadoes was an EF3 that occurred near Clarksville, Tennessee, which killed 3 people and injured 62. Tornadoes also occurred in the states of Florida, Alabama, North Carolina, Mississippi, and Kentucky. This video is not about this tornado outbreak, however. I just wanted to provide some context as to what exactly occurred outside of our local area on this day. Because to be frank, the weather in our area that day was very uneventful, but we'll get to that. First, I want to walk you through how the storm system affected northern Florida at large. Severe thunderstorms began to affect the state beginning at around 3 a.m. on the morning of December 10th, when this offshore severe thunderstorm affected Escambia County. The next severe thunderstorm was at 4:38 a.m., this time for Okaloosa and Santa Rosa counties. Severe thunderstorms would continue to occur as the system developed, but I think you get the gist. The National Weather Service office in Tallahassee issued 11 severe thunderstorm warnings and 7 tornado warnings on December 10th. NWS Tallahassee is the station that covers most of, if not the entire Florida Panhandle, so I think it's fair to say the Panhandle had a very active weather day on the 10th. So what happened over here on the first coast? Well, in terms of severe weather, not much. The IEM archive that I use to research severe weather events returns no severe thunderstorm warnings or tornado warnings issued. Now, there were some special weather statements on the squall line due to wind gusts between 45 to 55 miles per hour, but nothing severe. The western portions of our area were under tornado watch, but nothing ended up materializing. So now that we have an understanding of the severe weather that occurred, let's take a look at the storm system and how it progressed. The radar loop begins at around 2 a.m. on the 10th of December. Storm cells are beginning to approach Florida from the west, prompting the first severe alerts. At around 4 a.m., we begin to see a storm near Pensacola strengthen and widen. This storm will be one of the few supercells that congealed into a squall line later on. By 6 a.m., numerous cells have congealed into a large blob of thunderstorms near the destined area. By 8 a.m., a genuine squall line was beginning to form, and over the next few hours, the squall line continued to develop further south into the Gulf of Mexico, tapping into warm, moist air. By 2 p.m., the squall line was approaching our local area. I was keeping a close eye on it, as it was still looking rather formidable. This squall had been maintaining strength and prompting severe warnings left and right for 6 hours. At around 3 p.m., I began to notice that the front of the line was beginning to disconnect from the stratiform rain behind it. There's a lot of loss in bright colors in the line, which indicates heavy rain and thunderstorms. By 4 p.m., the structure of the squall line had completely collapsed, and from there, the system would continue to weaken, and any thunderstorms cleared out of our area around the 6 p.m. hour. I intend on doing a video in the future discussing squall lines, QLCSs, and derechos, because if there's one thing I still have trouble understanding about our area is why these systems seem to fall apart as they approach the I-95 corridor. Zooming into our area during the arrival of the squall line may help shed some light on the situation, though. In the first half of this radar scan, we see a line of what the radar interprets as light precipitation moving outward from the storm to the south. This is away from the line's relative movement direction of northeast. We have talked about this phenomenon before on this channel. It's a gust front. This typically occurs when a storm is weakening, causing a large amount of cold, dense air and heavy rain to fall down to the earth as the storm collapses. This can send out a burst of wind in any direction from the storm, but usually moves in some relation to the storm's relative forward motion. What the radar sees as rain could be small rain droplets being blown forward, or it could be leaves and other small debris being kicked into the air due to strong wind gusts. We were outside to record the gust front of this storm, which you will see at the end of this video. Squall lines are very sensitive systems. They maintain their strength by forcing warm, moist air to rise in front of the line, causing it to quickly condensate into clouds. If this source of warm, moist air is cut off, a squall line will quickly collapse. What likely happened is this gust front helped contribute to the destabilization of the squall line, robbing the storm of much needed fuel to keep its strength up. It must be noted that this is likely not the only reason that the squall line collapsed. It was also generally moving to a more unfavorable environment, one with a lot less inherent heat and moisture than what was present when the line was blasting through the Panhandle and had the Gulf of Mexico right below it. Also keep in mind that this squall line had been going for around 7 hours by the time it began to destabilize. While it's possible for squall lines to last for many more hours, even over a day, it's not very common for them to maintain structure for very long. This is especially true during the winter, when there is by default less moisture in the atmosphere to work with on most days. With all that being said, I hope you learned something new about squall lines today, but let's get into the footage.
Alright, hello everybody, welcome back to another episode of First Coast Storm Tracking. It is December 10th, 2023, and we have another storm system just about a week after the last one. This one's a little bit of a different setup, as you'll see in the video. I'll explain further, but we're dealing with a squall line right now. A lot of the lightning is embedded like way far in the storm, so we're probably not going to be out here for long trying to get shots. But my main goal for being out here right now is I wanted to get a shot of the gust front coming in on the squall line because it has had consistent 45 to 55 mile per hour wind gusts pretty much the entire time it's crossed the peninsula. So, yep, that's what we're doing. And then we're going to go inside because it's probably going to rain for like the next 2 hours. That's the plan. Right now, I'm just noticing the scud getting kicked up a little bit. Something I will also talk about further in the video is land spouts. A lot of the special weather statements have been warning about land spouts, and technically Clay County isn't under a tornado warning, but the county directly to our west, Baker, is, so like I don't really think it makes that much of a difference personally, but it's me. So yeah. I will say this storm system was overall looked like it had a lot more vigor early in the day. There was a lot of severe thunderstorm warnings and tornado warnings in like southern Georgia and the Florida Peninsula. And then last night there was apparently some very strong tornadoes in Tennessee. I don't know what rating those are yet. It's probably going to take a few days, but it's not looking great there. So usually this happens once the storm system gets this far south. It's kind of lost a lot of its punch, but you never know. Interesting things can still come out of it. Like I said, basically every episode I do here, like what I end up writing and stuff, this is kind of like a learning experience for me out in the field because, like, you know, now I'm learning about land spouts and stuff today because of the conditions that's set up. So, yeah, now y'all will be too. About 10 miles per hour right now, sustained. Get it back on the, see the trees down there. Oh, here it comes. Alright, hold the camera. See it coming in waves off the water. 12. That's a good gust. That's a good one. That first one. Look, you can see all the leaves. Yeah. Alright. Well, we're in it now. Yep. 16 again. Woo! 21. Woo! 26. There you go. I was waiting. I'm trying to get this. Yeah, I'm starting to feel some raindrops, and I'm sure it's picking up on camera. I'm starting to see narrow bands of precipitation coming in down there. The front of the storm is definitely past now. I can see it over us.